In this video we're talking about discrete probability distributions. So I'm going to work through this bit by bit. I'm going to describe what they are and go through a few questions, go through a few definitions as well. So let's just read through the sheet that you should have from the booklet. A discrete probability distribution is simply a list of the values a random variable can take along with the probability of each value being taken. So when we've got a discrete probability distribution, then we can only get certain values. So a good example would be rolling a dice. So the only numbers which can come out of rolling a dice are 1, 2, 3, 4, 5 and 6. So you can't get 1.5, you can't get 7, you can't get 600. You can only get those particular values. So they are so it's discrete probability distribution. Okay. As we know that there is a finite list of outputs or finite list of values that this variable can take, then all the probabilities for those must add up to 1 because they're the only possible outcomes of an event. Okay, let's go on to a further definition. So a discrete uniform distribution. This is a discrete probability distribution where all of the probabilities are the same. So uniform means they are uniform throughout the distribution. So again, let's talk about this example here. So it says complete the probability distribution when you roll a fair dice. So we roll a fair dice. The numbers that can come out of this are 1, 2, 3, 4, 5 and 6. And the probability of each of those numbers is 1 over 6. Okay, so they are identical. So that is a discrete uniform distribution. We can write that like that. We can use a capital U, so x is distributed uniformly from 1 to 6. This table here is a very common notation and way of describing a discrete probability distribution. So we have the value of x, and these are the possible values we can have, and the probability of the variable being equal to that value is written in there. Okay, should make sense. Okay, so let's do a couple of questions. So the discrete random variable x has the probability function shown in the table below. So there we're given the table. So the values that x can take are -2, -1, 0, 1, 2 and 3, and each one has a given probability. And the question says find the value of alpha. Okay, so we're going to use the fact here that if we add all of those up, we will get 1 because those are the only things that can happen. So we can solve that. So alpha is equal to 0.2. Okay. Find the probability of x being greater than -1 or less than or equal to 2. So if we look at this, so we'll just be careful with the signs, I suppose that could go wrong. So greater than 1, so I'm after this here, and less than or equal to 2, so I'm after those 4 there, aren't I? So that is equal to 0.3 plus 0.2, plus 0.2 plus 0.1, and the answer is 0.6. Okay. Right. Okay, so let's move on to another example here. So this time I'm given a discrete random variable y has the probability function of this. Now this is written in a different way, and sometimes we see them written like this, and it can depend on which one's the easiest to lay out. I suppose it comes down to the number of values that y in this case can take. So what this is telling us is that the probability of y being 0 is k times 2 minus 0. The probability of y being equal to 1 is k times 2 minus 1. The probability of being equal to 2 is k times 2 minus 2. So we can work out our probability of the variable taking each of those values. Same thing for 3, but we have a slightly different calculation for y equals 3. So that would be k times 3 minus 2. And this here is saying the probability of anything else happening is 0. So basically they can't happen. So what I'm going to do is I'm going to write this out as a probability distribution table. I'm going to write out the 4 different values that y can take, and I'm going to write the probability of each one taking place. So let's think about this. So if it's 0, it is k times 2 minus 0, so that's 2k. If it's 1, it is k times 2 minus 1, so that becomes 1k. If it's 2, the probability is k times 2 minus 2. 2 minus 2 is 0, so 0 times k is 0. And the probability of y being equal to 3 is k times 3 minus 1, so that is k also. So what I can do here is I can use this to say, okay, well 2k plus k plus k, that plus that plus that plus that, is equal to 1. So 4k equals 1. So k is a half. Is a quarter. Okay. Find the probability of y being equal to 1 unioned with y being equal to 2. So that is those two there. So that is going to be a quarter plus 0. So that is going to be a quarter as well, isn't it? Okay. Let's go on to the next page of this. And what I would like you to do now is pause the video. I want you to have a go at those, and then when you restart the video I will go through these. Okay, so pause now. Okay, so let's go through these. Hopefully you've had a go. So discrete random variable x has a probability function shown in the table. So if x is 0, it's a third, 1 is a half, 2 and 3 are an unknown value that we need to find. So what I'm going to do is I'm going to say 1/3 plus 1/2 plus alpha equals 0. So that I think is 5/6 plus 2 alpha equals 1. So 2 alpha is 1 minus 5/6, which is 1/6. So alpha equals 1/12. So that probability there is 1/12. And if you wanted to just check it, you could just add those up, and those should equal to 1. Okay, so that's that. Then I want to work out the probability of x being greater than 1 and, sorry, I've written that down, I'm going to 3 there, and less than or equal to 3. So actually it's those two there, because it must be greater than 1. So 2 and 3 are the ones that I'd be interested in there. So that equals 1/12 plus 1/12, which equals 1/6. Okay. Discrete random variable y has the probability function of this. I'm giving it in this notation now, so I'm going to write this out as a table. So this is telling me the only values that can happen here are 4, 5 and 6. So if I put 4 into here, so the probability of y being equal to 4 is k times 4 squared minus 9. So 4 squared is 16 minus 9 is 7, so that's 7k. If I put 5 into here, don't forget it's the value of x that is going to give me the probability, so that becomes 5 squared minus 9, which is 16. 16 times k is that, and the same thing with the 6, so 6 squared is 36 minus 9 is 27k. So that and that are different ways of expressing the same thing. Okay, I now know that 7k plus 16k plus 27k equals 1. So I can solve that for k. That's 50k equals 1, so k equals 1 over 50. So what this really means is that the probability of getting a 4 is 7 out of 50. The probability of getting a 5 is 16 over 50. And the probability of getting a 6 is 27 over 50. And if we add those up, we get 1, don't we? Or 50 over 50. Okay. So the probability of y being equal to 4 is 7 over 50. I've actually worked out the others as well there, haven't I? Okay, this table gives a discrete uniform distribution. Discrete uniform, so the fact that it is uniform means that, and this is the key thing about the word uniform, is that each of those are the same. So I have 5 boxes that must add up to 1, so each of those must be 1/5. If I add those up, I get 5/5, which is 1. Okay, so the probability of z being greater than 3 is those 3 there. It can be equal to 4, 5 or 6. So that is 1/5 plus 1/5 plus 1/5, which equals 3/5. Okay, so those should have been where you got to on those. Okay, hope that was helpful. Thank you very much.